All right, day 3, probability and statistics. We're having a lot of fun, are we? All right, so multiplication rule, as I said, I heard a yes. That's for and. Addition rule for or. The problems won't always have ands and ors in them, and you kind of sometimes have to think, oh, if I thought of these as separate events, would I put them together with an and or an or to make the problem make sense? So, oops, next page. Independent events. So we'll define some words. So, two events are independent if the occurrence of one event doesn't change the probability of the other event. And so independent events might be like if you roll a die. Those are independent events. If you think that 4 out of 5 dentists recommend Crest. So, I'll put 4 out of 5 dentists here. If you think that 90% of your computer chips are good, or maybe potato chips are good, I don't know, 90% of your potato chips are good. How good one potato chip is or knowing how good one potato chip is doesn't affect the potato chip sitting next to it in the bag. That one dentist recommends Crest shouldn't be affecting how another dentist recommends Crest. They should be fairly independent. Events that aren't independent, we would call dependent events. And those are events where the probabilities change from one occurrence of an event to another because we know that some probability has already happened. We'll look at different ways to figure out probabilities for those. So the classic dependent events are I've got a deck of cards. I deal out a card. And I put it down on the table or I put it into your hand. And then I want to find the probability that the next card coming out is something. So I'll say cards dealt. Oops, dealt. Dealt. And their probabilities. Conditional probability. So we have actually 3 different words here we have to define today. Conditional probability is the probability of an event happening given that you've already know something about another event happening. So, for example, so they're written like this, and if I want to know the probability of getting a king given that there are 3 kings showing on the table, is a conditional probability. The probability of getting a king is 4 out of 52. But if I've already dealt some cards out and I see 3 kings out there already, then that probability of getting a king has changed. There's only 1 king left in the deck. Okay? So that probability is a conditional probability now. But I've got some more information. Okay, so let's see how we use these two. If your events are independent, you get to multiply the probabilities. It's just like an addition. If the events were disjoint, you just got to add the probabilities. All right. Multiplication, you multiply the probabilities. Pretty easy. Pretty straightforward. Okay. So let's look at an example for independent events. So we got 5 light bulbs in a box. 4 of them are good. 1 of them's bad. What's the probability of getting a good light bulb? If you reach into this box and you close your eyes and you don't jiggle the bulb, what's the probability of getting a good light bulb? Okay. So what I'm going to do is I'm going to pick a light bulb out of the box, test it, see if it was good, put it back in the box. And then I'm going to close my eyes, or maybe somebody else is going to come and choose a light bulb out of the box. Test it and see if it was good. Those events are independent events. And I want to find out whether I got the probability that the first one was good and the second one was good. So I'm talking about multiplication rule. So the probability of first good and second good is just probability the first one is good times probability the second one is good is 16/25. Okay, so that's for independent events. I can identify independent events, number one, by the words I have replaced, or by seeing that I have a probability of events that doesn't change. So if I keep replacing these bulbs, they're always going to have an 80% probability of being good. So that probability doesn't change. So I must not have a conditional probability. So I am into independent events. All right. Dependent events. There's also a multiplication rule for this, but it's a little bit different. So the probability of event A and B happening is the probability of event A times the probability of event B, with the knowledge that A happened. And so this I read as B given A. So let's go back to our cards problem. Let's find the probability of getting a king on the first card and a king on the second card. Okay, so that's going to be the probability, and we're dealing cards, so we're dealing without replacement, so we're into dependent events. So that's the probability of getting your king times the probability of getting a second king, given that we already know we've got a king in our hand by the fact that we want the probability of getting a king on the first card. Okay? Probability of getting a king, there are 4 kings in a deck of 52 cards. So if I've got a king in my hand and I want the next card to be a king, there's only 3 kings left in the deck. And how many cards are there left in the deck? 51. So this is 12 out of whatever 52 times 51 is. 26, 52.